Hi everybody, it's Carlos Zapata again, and I'm here to talk to you about the solution to the problem we posed last time. Now, before we get into the actual solution, let me remind you that this was more of a modeling problem than a mathematics problem. So I am going to work within some assumptions, and I'm going to walk you through my way of thinking into those assumptions. But once we can solve it as a mathematics problem. We can apply some basic mathematics tools that everyone is familiar with. But some of you might have done different things, and I don't want you to leave this video with the impression that if you did something different, it was necessarily wrong. As I said in my last video, there is no right or wrong solution to this problem in principle, especially before we assume anything about how we're going to tackle it. Okay, so that being said, let's try and make some assumptions and try to work through the solution. All right, so let's begin with the solution. What are our assumptions? Well, first of all, we're going to assume that the table is homogeneous. And symmetric. In other words, square. All right, so what this means is that we are thinking of a kind of table that looks like this. It's made of all the same material, completely homogeneous, and the legs are somehow placed at those ends. Okay, so I'm not going to pay too much attention to the drawing, but this is the idea. And then there'll be a little leg down there. Okay, so how are we going to tackle this? We're going to apply the theory of momentums, as many of you might be aware, and we're going to look at the table from the top as a square. And we're going to place an object here. So our object is going to be located here. And we're going to obviously simplify that the object applies the weight here in a single point. Okay, so legs are here, 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 and here. So these are legs. And obviously the center of mass of my table is in here. Okay, so that is the center of mass. So what's going to happen is essentially this is the axis about which our table is going to move. And so we need to apply momentums through this axis, through the diagonal. Okay, so let me draw that again. So we're going to have a diagonal through here, something like that. And so basically, the weight of that little object here, let's call it W, it's going to be compared with this distance, let's call it L, to the weight of the table applied there, let's call it M, but then apply with that distance. Let's call it L prime. Now, a little bit of geometry obviously tells you that L equals L prime. And therefore, if we're taking moments around that particular point, we'll be writing something like the weight of the object, W, times L must equal the mass of the table times L prime. But obviously, L and L prime are the same. So this implies here, this implies that the weight of my object should equal the total mass of the table. So this is a very simplified solution for a problem that can be very complex. And before closing it off, I'd just like to remind you that any other solutions that account for more complex situations and for more geometry of the table and involving more details about the physics and the statics and so on are perfectly fine. The important step here, the important lesson, is that you go through the process of modeling. You go through the process of digesting the information, extracting what's essential, and then formulating a problem. This particular approach is the most straightforward, most streamlined approach, and as such, it misses a lot of the components of reality that can be attributed to this problem. So if you wanted to apply this to a real table, you would probably have to adapt it and make it a little bit more sophisticated. But this is one first approach. And this is just an example of how you can make a statement about something that doesn't even exist and you have to imagine, and simplify it to the point where you can just apply a very simple mathematical argument to give an answer. So I hope you enjoyed it. I'll see you next year.